All right, that was 1. Here's 2. Okay, we got linear. Okay, now let's do quadratic. Okay, so let's take a look at that one. Quadratic. Here we are. Down here. Actually, you know what? We can cover the inverses because we don't care about that part. So hey, the framing should be a little bit better on this one. All right, second parent function. This one should also be pretty familiar. Okay, this is a familiar shape, that familiar U shape. This is quadratic. It's a quadratic parent function. Okay, this one, the equation for that one looks like y equals x squared. Okay, so instead of it just being y equals x, we got y equals, and then it'll be x squared. Okay, so what happens there? Well, let's talk about points on this one first. This one also goes through the origin. It goes through the point 0, 0. Okay, goes through 0, 0. Goes through that origin, which means that my x-intercept and my y-intercept are also going to be both 0, 0. Okay, so we got that taken care of. Good to go. Okay. From there, we share this other point. We got 1, 1. That's right here. Okay, we got 1, 1. You know, if we keep going, we go 2, and then what happens is you end up at 2, 4. Okay, so if x was 2, we got to square that. That's what y is going to be. There would be 4. Okay. Cool thing that happens with these quadratic functions is that they're kind of a mirror from one side to the other. So like over here, if I went to -1, it's still +1 because we end up squaring it. Same with -2. We plug in -2, -2 squared, we get +4. Okay, so that's kind of nice. It makes it easier sometimes when you're figuring stuff out. Oops, that would be right there. It makes it easier sometimes when you're figuring some stuff out that you can, figure out, that you're going, that you figure out one side, you can kind of mirror it over the other. You don't have to figure out all the other stuff. Really should be putting arrows on that guy too. It's going to continue going up, but then that's going to change what happens with our domain and range. Check it out. So domain is supposed to be all the possible x's. So domain actually doesn't change. Okay, it's going to be that big R. Oh my gosh, that is so terrible. That has got to be one of the worst I've ever seen. Or hopefully this is better. -infinity. Oh gosh. To infinity. Oh, that was not good. Okay. But the range, though, this one changes. If you check it out, this one, the range, we're thinking about y values, thinking about what possible y's we've got going on. If we're doing this and we're going up from here, and that's all we're doing, then it doesn't go below 0. Okay, so my x's don't go below 0. So what we would say is that if we're talking about our lowest thing, So 0 is our lowest x. Okay, our highest x is actually not, there is none. I just totally marked on that page. There is no highest x. Okay, it's going to keep going, it's going to keep on going. So 0 is going to be less than or equal to x. Any x that's bigger than 0 works. Why did I put x? Oh gosh, this is a great day. This is a great day. It's a great day. Please, for the love of all that is Falcon, here you go. 0 has to be less than or equal to y. Much better there. Okay, y is what we're talking about when we're talking about range. Okay, so it's possible y value. So any y value that's bigger than 0 will be a possible y value that would be on this. Okay, the other way we would see this in interval notation, this other kind of notation, when I say or, that's what I'm really talking about. Or, okay, what we'll see is this. 0 to infinity. And don't worry right now about that notation, okay? Don't worry too much about what's going on here, okay? What we talked about mostly was this kind of notation with like inequalities and stuff. That's what we did on Friday. What we're going to be doing now is we're going to move into this thing that I like. It's a lot more slick. It's called interval notation. It's so much easier than the inequalities. I like it. And we're going to start transitioning into that. So here's quadratic. There you go. Quadratic parent function. Again, this shouldn't be a new function. It's one we should be slightly familiar with, but there we go. 2 out of 9 done.